Hello, everybody. Welcome to Physics 7B. I wanted to create a video here at the start just to introduce myself and introduce the course just a little bit. My name is Dr. Lohorn, which I know sounds maybe a little bit weird, but it's a relatively simple name, I think, because if you were to look at the name, it's just really, two words, just like that. And you simply pronounce the two words, and then you've got my name. So all is well. You'd be surprised how many people mispronounce it, but it's really not that difficult. Hopefully, as we go through this video, I can give you a few things of introduction to help you get a feel for how the course is going to be run. And of course, if you have questions, don't hesitate to ask later. So let's start here. There's my email address. I wanted to mention my office hours, which will be conducted, of course, via Zoom. I think we're going to have 2 office hours this week as we get started, but as I've got a bit of a crazy week this week with a lot of things going on personally. But then after that, I hope to ramp it up and have more than 2 hours per week to try to be as available as I can be for you guys. So let's move forward. What are the various meetings that you are responsible for and things that you have to keep in mind? First of all, lecture. You don't need to be anywhere at any particular time. I will be posting 1 pre-recorded video per chapter. And by the time you see this video, you should already see at least chapter 17 posted on B courses. And feel free to watch that or don't watch that or watch it at double speed or however suits you best to get the material. In addition, we have your lab section and your discussion section. These each meet twice per week. Even if on the syllabus it doesn't list that you have a lab experiment, you still have lab section. These will be conducted live so that students who want to get some feedback or want to have interaction with other students, they can attend those. They will be recorded as well, or at least we're going to record some subsection of them so that they're all not recorded, which seems a little bit redundant. So if you are taking the course remotely or asynchronously, you're in a very different time zone, whatever, you can miss these section times and still get everything you need. So as you can see down below, there are no attendance requirements. If you are able, we highly recommend that you attend lab and discussion for these times each week. It'll give you a chance to work on problems with other students and also get feedback in real time and ask questions of your graduate student instructor, your GSI. So if you can be there, be there. We think it'll help. If you're struggling in the course and you haven't been attending section, make a change and try to attend section and see if that gives you some help. We understand that there are difficulties. You signed up for a particular time, but maybe you thought that time didn't matter. Maybe you can't make that time now. If you can officially switch sections, go ahead and do that. But if you would like to attend another time in a particular week, or maybe overall things come up, just notify the 2 instructors, the one that you're not attending and the one that you will be attending, to let them know. I should also add that if you attend the same section each week and you're actually faithful to that, it'll give you a chance to get to know your graduate student instructor a little bit better, for them to get to know you better, and there could be just better interactions there overall. One additional thing I should add about these sections is that if you are comfortable, we're going to request that you turn on your video during section. This should build a little bit better sense of community when we're doing a class like this remotely. We think it'll help just sort of create a bond a little bit better between students and instructors and help us all feel like this is something that we're in together and that we're working on together and trying to succeed in the course. Of course, if you can't, or if that's not something you're comfortable with, we're not going to require that. But as many of you as can, that would be helpful. Moving on a little bit, our course materials, everything is going to be on B courses. So if you need to know it, it will be posted there. The one exception to that being the homework, where we're using a third-party online homework solution, masteringphysics.com, where you'll submit your homework. But other than that, all communications will go through B courses and all your materials will be posted there. There have been some questions about the textbook and materials and the things you need, and how to get those. I sent out an announcement about that. The text that we're using is by Giancoli. There's a custom version for Berkeley, but the only real customization is that they've broken it down so that volume 2 contains what we're covering, instead of some of it being in volume 2 and some of it in volume 3 and some of it in volume 1, et cetera, et cetera. if you can get this material in another textbook or whatever, that's totally fine. If you want the physical copy or if you want the electronic copy, that's totally fine. All of that really doesn't matter. The thing that do matter is the 7B workbook, which has materials for your labs and things that we're going to cover in sections, and the Mastering Physics, which you get a code when you buy this textbook. So I think you may be able to get a code separately as well, but that's something you'd have to look into a little bit more detail. If you're taking the class remotely and you're not able to get this package at the bookstore, we're working on trying to get the workbook to you, but that is something that is still in process. We'll do that as soon as we can. We're waiting with the publisher, just trying to make that happen. So let's see, those are our course materials. Let's talk a little bit about what I expect from you and the ways that you should conduct the course and the ways that I feel will help you best learn the material. First of all, when it deals with the lecture, I would say that before you watch the lecture material, look up the chapter in the book, look at what we're supposed to be covering, and just try to get through that material for the day. I don't expect you to really understand everything when you watch that or when you read that chapter, but just try to get a feel for what's there. Get a basic understanding, skip over parts that you don't understand, maybe make a note of the parts you don't understand. And then when you're actually watching the lecture file, you can more learn actively. You know the things that, well, made no sense to you, or the things that you need to know, and you can sort of look for clues in the lecture to help with your understanding. Also, it can help with the homework, because if you've already read the material and maybe you've already even looked at the homework, you are listening to the lecture looking for solutions, things that will help you solve the homework problems. So read the material for the day, don't dwell on it, but get through it. Get the pre-lecture file, which will be on B courses. Think of this as sort of a skeleton structure for the slides that I'm going to be using that day. I will start with the exact same file when I'm presenting the lecture, and then I'm going to fill it in with all the notes and all the annotations and all the extra information you need. So you could use this to take your notes as well, or you could just wait until after the lecture and get my notes directly just as they are on the video. I don't know how you learn best, so whatever is best for your learning process. So you have the blank lecture file, and then I'm also going to give you the filled in lecture file. And in the middle, you've got the video, which you can watch. You can take notes. You can just sit back and let the physics wash over you and just enjoy the physics. Maybe that sounds ridiculous, but take notes if you want to. If you don't, you're going to have them anyway. Listen, watch it fast, whatever you need to do in this process, you're going to have everything that you need from the lecture to learn. So make that an active learning process, however best suits you. With regards to the homework, you're going to have a homework assignment for each chapter. They are already set with due dates, and they will typically come due a few days up to a week after we finish the material or after the material is scheduled on the syllabus. We do not accept late homework. It just causes a whole lot of problems. And also, it's something that you should work on together. I treat homework not really as a test, even though, of course, you do get penalized if you miss problems or if you take guesses with the wrong answers, there are penalties. But the best way to approach the homework is to get together, make friends, work on the homework problems together, come up with solutions, discuss things. And then once you've come up with solutions, go post your answers on Mastering Physics. So I expect you to work together, but also not to just take answers from other people. You should all be contributing. You should all be learning. Help each other out with the homework. It's kind of a sad situation that it's difficult to do these problems on your own because you're going to get stuck and then you're sitting in a room alone. You don't know what to do, and it's sad. And there's no way to get out of the stuck necessarily. But if you're working with someone else, they might have an idea, and then you're a little unstuck and you can proceed a little bit more. Or maybe the next time one of your study partners is stuck and you can help them get unstuck. So working in groups is part of learning physics. It's much better together than trying to do it on your own. Continuing forward, we're going to have 2 exams in this course. These are the dates. But what time on those dates is a little bit up in the air, and exactly the format of the exams is still a little bit up in the air. I'll let you know as soon as we know. We are planning on the final not being cumulative. So this midterm will cover the first part of the course. Final exam will cover the second part of the course. The problem is there is some material that carries over. So for instance, for the second part of the course, you have to know some earlier things to be able to do any of that work. So while the final exam won't directly cover material from the midterm, there is material that you still have to know to be able to do the work on the final exam. So, except where necessary, it's not cumulative. All right. Let's see. What else do we have here? Grading, relatively simple. You've got homework to do. You've got little laboratories that you're going to do. And then you've got these 2 exams. They'll be weighted in the percentages that you see there. And then finally, what is our tentative schedule? I leave the word tentative there because, of course, things are going to happen. Things are going to come up. We may have to shift things just a little bit from time to time. But I feel that we'll mostly stay on track with this. So you can see the various assignments or the chapters that we're going to be covering on given days. Since we don't physically meet on those days, just assume that, well, before 6/24, sometime before there, I will have posted the lecture video for chapter 18. Sometimes it'll be quite a few days in advance. Sometimes it might be closer to the day. But my plan is to keep posting things well in advance of these due dates so that you can get ahead in the course if you want to or need to. Here are the sections we're covering from each chapter. So sometimes it's the entire textbook chapter and other times it's just part of it. So these are the things you should be reading before you watch the lecture file. You can see we have some designated days for labs. So here on this particular Thursday and Monday, when you're in your lab section, you'll be working on those laboratory experiments. And you'll see more about that when you meet with your GSI in the first lab section. And then finally, probably the column you most want to pay attention to here is when things are due. And these are already set up in stone. The homework due dates, you can see them here on Mastering Physics each time. I should point out that all of these due dates, it's always at 11:59 p.m. on that particular day. So you'll see a bunch of homework due dates, and also scattered through here, you have your lab write-up due dates as well. And I tried to give you plenty of time after whatever particular assignment is covered in the course to finish that up. One thing you might see that's a little bit odd is this homework due date here at the end. You should really work this homework before the final exam, but I'm not going to make it due until that Friday at 11:59 p.m. because I understand, well, you might be wanting to focus on the final exam itself and perhaps a little less about whether you submit everything properly and get that done and get it in on time. So do that earlier, but you've got a little bit of leeway there if you need a little extra time for submission. So let me put just an extra box around this. There we go, because you really want to focus on those and keep in mind the due date or the due time on every one of those due dates. Let me point out a little bit more in this schedule. Let's see, a different color. How about this one? The course breaks down into 2 distinct segments. So here at the start, we're doing thermodynamics. And you can think of this as sort of building on itself, like all of this sort of ties together. It's one big topic that all fits together as one thing. And then for the rest of the course, we're doing electricity and magnetism. And all of these topics sort of build on themselves until we reach a conclusion in chapter 31. But then again, like I said earlier, notice midterm exam covers through chapter 23. So that means all of this stuff up here at the top, well, that's not going to be on the final exam. However, these 3 chapters, because this is building through electricity and magnetism, some of this stuff here you're going to have to know to be able to solve problems that are covered down here. So while I may not specifically give you a Gauss's law problem as something that I'm testing on the final exam, you might need to know something about it to be able to do something that sits down here. So just keep that in mind, and I can answer more questions as we get to those parts. I think that is everything that I want to talk about here in the introduction. So if something doesn't make sense or if you have questions, by all means, email me. But welcome to the course, welcome to Berkeley, welcome to the summer, welcome to this weird summer, and I hope that we all have a wonderful class together. Have a good day.